Hi, and welcome to my shop. And thanks so much for coming and joining me, keeping me company while I work on the radio in the box here. If you're new to my channel, just a little word of warning, these videos are barely edited at all. So it's essentially a live video. That means the pace is a little different from many of the videos you see on YouTube. So if you're a subscriber, you must know, if you've been watching lots of my videos for the last while, that there's a number of projects that I put into abeyance. I had to set aside for a couple different reasons. All those projects, they're not gone away. They will get in here and they will get finished. But unfortunately, it's getting to be a significant number, maybe 4 or 5 projects that I hadn't quite finished. So I don't like it when that happens, but I can't change things. Reality is reality, yeah. So, and this is kind of a reality TV channel, if you like. It's a real one, though. So, great. Here we go. So, what do I know about this radio? I know it's in this cardboard box, and that's about the end of it. So, let's get it out of the box and start checking it out. Now, offhand, I don't think there's much wrong with this radio. This is owned by a friend of mine who has a number of old radios that I am working my way through slowly, and I'm pretty sure he told me this one's working, but I could easily be mistaken. So here's kind of how the process is going to go. I think this is probably going to take 2 1-hour, maybe 3 1-hour videos to get through this radio. Don't really know what's coming next. None of this is pre-planned or scripted in any way, so don't really know any better than you what's going to happen next. So my objective is today to examine the radio carefully, perhaps plug it in and test it out, and can't plug it in with this. Test it out, learn about it a little bit more, find out what's been done with it, try to assess what might need to be done. Hey, here's some more wires stuck in here. Okay, observations coming already. This is the dial string coming out of here. Okay, so there's a problem. There we are. So as I said, probably 2 to 3 videos. This one, checking it out, perhaps playing it, seeing what kind of condition it's in. Next video is fixing it up, making the repairs that are needed, like for instance a new string, cable, or cord rather. And the last video would be tuning the radio up for performance, which is doing the alignment work on it. That's the plan. Along the way, we're going to get to check out my new camera, which replaces it's identical to a camera that I'm replacing. So this is my kind of close-up camera. I've been missing this guy for a while, but I can do some pretty nice close-ups with this, I hope. Okay. Let's get going. So what is this? So luckily it has a nameplate on it. It's a Philco 47A. 115 volts, 25 or 40 cycles. Now that's interesting. 40 cycles? Doesn't say 60 on it, but that's not a concern. 40 watts. I'm not sure what that says right there. This radio will serve as a fine phonograph. Connect a Philco record player here, right there. So we can make some important observations right off the bat. Here's some more string here. Seeing this big transformer is a big observation. So this radio, I'm going to guess, is from the 1930s, but I could be quite wrong about that. I think it's the late 1930s. I'm judging that by looking at the tubes, especially this one here. The fact that it's this size but has a big transformer. So this is not your classic 5-tube radio without a power transformer. That makes this a safer radio to work on in my shop here. We can look at the tuning capacitor, this guy here. We can see it's got 2 sections to it. That means this isn't the highest quality radio. Higher quality radios will have 3 sections in their capacitor. More tuned circuits than this one has. It has a light here. That's probably powered from the same power that powers all the tube filaments, probably. The speaker has its own output transformer here. So what I'm doing right now is I'm just observing everything I can in the radio, getting visually familiar with it, looking at a few odd things like this. And we have a wire here. Now I don't have the cabinet. My friend has given me the, here's the power cord here, just cut off. He has given me this without the cabinet, so we have to make a guess here. And the guess is, well, the question is, does it actually have a special antenna, something like this one, on the back of the radio, which I don't have? I'm not sure of that. I'll have to ask him. The important thing about that is those kinds of antennas are tuned and form part of the tuned system of the radio. What's sticking out of here is a wire and another wire, two wires kind of sticking out. It could be they went to the antenna, they're about the right length, or it could be these are intended to hook up a long wire antenna. You can see somebody had a piece of wire hooked up to it. Without that special antenna, special tuned antenna designed specifically for this radio, the performance of this radio would be highly degraded. So we'll find out down the road just what the story is and the like. Now if we look at the speaker again, it's a little hard to see, but if you look down here where you expect to find on a modern speaker a big magnet, or a magnet anyway, this one has a coil. So that's a big message about the age of the radio. Again, that suggests 1930s. And what's happening here is the strength of permanent magnets wasn't all that great back at this time. Certainly earlier, they certainly weren't strong. And so to build up a strong magnetic field to make the speaker work, the designers of this radio, and almost all other radios like it, used a trick where they would put a coil to generate an electromagnet, run a current through it, of course, to make the magnetism. But the trick is that current would be part of the power supply, and in fact the coil forms part of the power supply filter system. This is very, very common, especially in the big old radios with the great big speaker. You can tell by looking at how many wires are coming to it. Just 2 wires coming to your speaker probably has a permanent magnet. 3 or 4 wires coming to it probably has a field coil magnet in it. So all good observations to make. You notice there's a coil, a couple coils up here, or a transformer up here. This is probably the antenna transformer, where the signal that develops in the antenna is passed through the transformer to carry on into the radio. This has to do, of course, with impedance adjustments and stuff like that, to make things work the best as possible. I see the tension spring for the string is still here. It didn't disappear. I'll leave it hanging there. So obviously if we tune nothing on this radio. Now that's unusual. Usually the string comes down the front here and goes on a bobbin. There's no bobbin here. So I see two holes in the cabinet. I guess the string goes through those holes, get onto the knob, and then probably comes out another hole. I'm not sure. So I will be looking for the schematic and other information about this radio. Probably I will find a stringing diagram which will show me how to attach the string. If you get an old radio like this and the string is broken, but it's still more or less in place, don't just yank it out. Once the string is out, it's actually quite tricky to figure out how to restring them. You might think it's an easy thing. It goes around here, it goes around there, doesn't it go there? Well, there's more than one way to skin the cat when it comes to that. So that's great. The radio appears to be in very good condition. On the top here, it's very clean. Well, sort of clean, not piled up in dust. The tubes have been polished up, it looks like. I can still read the tube type here. So another thing we'll be doing along the way probably is testing these tubes. But ultimately, if the radio can work with the tubes it has, that's kind of enough of a test right there. Very good. Chances are these tubes are not original. Philco. Let's pull this one out. This is the power supply rectifier tube. It's a bigger glass tube. Let me pry it up here. Mostly because this is the rectifier tubes get very hot. So this is a number 80, which is an early rectifier tube, very, very common, replaced with a 5U4, I think. I'm not sure. Don't quote me. Here's another thing. Since this is live and not scripted, I'm not doing research and then coming in and telling you what I just read. I'm just doing this off the top of my head as I go. So more than occasionally, misinformation comes out of my mouth. Yes, I'm adding to misinformation in the world. Shame on me. So you need your thinking cap on, and you need to understand that I'm actually wrong at times. What I'm saying is not true, and other times what's in my head is not what's coming out of my mouth. So you need to be aware. I don't edit that stuff. I don't correct that stuff. Usually if I'm wrong about something, I figure it out eventually. So we're going to tip it up with the big heavy transformer downwards and look underneath and remark, nobody's done a darn thing to this radio. I think it may be entirely original here. It's a good chance this has been replaced along in its life because these capacitors had a relatively short life. It says Philco on it. I think we're looking at an all original here. These may be replacements. There may have been wax capacitors like these here. Someone may have replaced these at some point along the way. These are also paper wax capacitors, but they have a plastic shell on them. And it can kind of fool you into thinking they're really superior, but you know, the paper that these were made with is not perfectly clean. It can have some contaminants in it, so even putting the paper capacitor into a plastic shell that is hermetically sealed doesn't guarantee a long life on these capacitors. Probably these were thought to last longer than these. For a radio this age, these capacitors are almost certainly sunk. This one's almost certainly shot. Turning this radio on with these capacitors in place, bit of a question mark. The other thing I'm noticing is there's not a lot of parts in here. Not many parts at all. So it would raise the question, is something missing? But chances are very low. Anything's missing. Here's the original cord. Still flexible, so I think that means the cord is made of rubber. Real rubber, I think. Even here where it's been tied in a knot where it's most likely to crack, I don't think there's any cracks. So why exactly it was cut off? It may have been cut off as a way to prevent somebody from plugging it in because there's something wrong with it. It may have been cut off because somebody wanted to use the cord on another radio. That can happen. So we don't know, but chances are there's a chance that this is telling me there's something kind of wrong with this guy, that maybe whoever had it couldn't overcome it, or really didn't care to overcome it, because it was time to get a brand new 1960s radio. Yeah. Okay, so we're going to take a close-up look in here. I'm going to stop the video. I'm going to fire up this other camera. We're going to see if it works. Works like the last one I had. I hope it does. Okay, we're ready to go. Now, just another thing about the videos I make. I'm not promoting any products. I'm not playing the promotional game. I get an invitation a couple of times a week to put advertisements on my channel or to accept products and do all kinds of stuff. I've decided firmly I won't do that. I'm not going to get dragged into the whole commercialization that's going on. So you may notice quite a number of YouTube video makers suddenly seem to be a level up in terms of professionalism, and advertisements are coming and products are being hawked and stuff like that. There's real money in that. I'm just not doing it because I'm not interested in it. I don't want to be beholden to anybody for anything except maybe the owner of the radio who I'm fixing up, who owns the radio that I'm working on. So consequently, I'm telling you, I went and bought this like anybody would buy it. This is picked for me. I'm not trying to promote it in any way, but you see me using stuff, you might get the idea that you'd like one too. That's not from promotion. I'm not trying to promote this, but I do like this camera. What I like about it is its ability to do close-ups. So I'm just going to test that out right now. At least the earlier one I had like this. This is a cinema camera. I bought the next step up. Here, I got it sitting right over here. The Studio to replace the Cinema. The Studio is a higher quality camera, but it will not do the kind of close-ups that this one will. So I've had to buy this. Let's just take a look through it. Fantastic. Okay, now I'm going to manually adjust the focus and see just how close we can get to things here. Oh, that's wonderful. Really close. I gotta re-aim it here. Excellent, just what I was looking for. So it's almost microscopic. Fantastic. Okay, now I'm going to set it to where it's going to be very useful focus-wise. This is what I mean by my videos are not heavily edited. Okay, let's work with it like that. We'll just start in the lower corner and we'll just kind of work our way through this radio. And what are we looking for? We're looking for anything we can see. That's what we're looking for. So, and I'll just talk about what it is I'm seeing while I'm doing this. So we're starting right here. It's the volume control. And looks like a slice in this capacitor here. And we're just going to go across the bottom. Looking at the solder connections on the back of the on-off switch. Now the type of wire here is cloth covered wire. That's a good thing. This is probably very stiff. These are really old. Probably very stiff. Yeah, they are. They're very stiff. The stiff is from the insulation inside, the rubbery insulation inside. The cloth, though, is usually quite resilient. So the chances of a bare conductor appearing here is quite low. If you have a radio, a newer radio, there's no cloth. It's just a plastic or rubbery insulation. Chances are those stiff wires, if you bend them, that's the end of the insulation. I think maybe there's one down there. No, they're all cloth covered. Very good, but I don't want to bend those, that's for sure. So we're looking at the bottom of the rectifier tube. 4 pins. Okay, we're not seeing anything too interesting so far. So is this a replaced capacitor? So I'm looking at the solder joint, and I'm thinking it is. But I can't be sure. If it's a replaced capacitor, there's a remote chance it's the wrong size. Generally speaking, though, this old capacitor would have been done in a radio repair shop by people who had the stock and knew what they were doing. The seam in the plastic there, does it look like it's cracked at all? Could be. These often crack. And once they crack, of course, there's no hermetic seal. But also they leak where the wire goes in and out a little bit. And there's a moisture penetration rate even for plastic. In fact, even glass has a moisture transmission rate, if you can believe it. Only metal will stop moisture. That's why your potato chips come in a aluminum bag, aluminum lined bag. So we're looking around, looking at the resistors. Are any of them discolored? They look like they've overheated. There's just really not many parts in here. Look at that solder joint. At the time this radio was made, it would have been made in a probably poor situation in terms of lighting, the kind of soldering iron they were using. Just the shop itself could have been extremely rough. Philco was a big name, so maybe not. Their factories may have been well lit, and they still could be using these huge soldering irons that you heat up in a flame and then stick them in here like so. So I look at the soldering here. Okay, I see no rosin on any of these connections, the dark material. But when I look down here at even further down here, I can see bits of rosin on these connections. Well, that's a sign these have been replaced. Okay. Don't see anything too dramatic. Here's some, well, these are clearly original Philco capacitors. Notice they just have a number on them, 30, 45, 195. Sometimes the size is not on these. It is though. 0.05, made in the USA. Okay, let's go across. Very small resistors, but look fine. Everything looks fine. Oh, there's a note, 95. 295. I wonder what that is. Something they no doubt wrote in the chassis when the chassis was made, so maybe this is a chassis 295 or something. Let's look at that name plate. Now we got the close-up camera, we can really read it. Code I-21 or 121. Don't know what that code is. Or is that? So let's read what it says here. And if I just figure out how to hold the camera right, here we are. Patented, licensed by the Canadian Radio Patents Limited only for the non-commercial reception of public radio telephone broadcast. Patented 1915 to 1930 inclusive. Licensed by the Hazeltine Corporation only for use in homes, for educational purposes, and for private, non-commercial use. Patented 1924 to 1939. So this has got to be at least late 1939. Could be early 1940s. Made in Canada, Philco Products, Toronto, Canada. I live about a little over an hour's drive to Toronto. 47A. That's about all we're going to get out of that, and that's that other note I read to you already. Connect a Philco record player here. Okay, well, I'm not sure I have a Philco record player to connect there. Incidentally, you can, if you dare, plug your Bluetooth receiver in there. If you dare. Some of the radios with the big transformer, maybe not so scary, but the 5-tube radios, a little scary to plug stuff into them. Okay, we'll keep going along here. I'm thinking about, well, why wouldn't I plug this in? I have ways of controlling the amount of power reaching the radio initially. Now there's an older, pretty old resistor there. So, you know, most resistors have this color banding of this sort. That's probably brown, black, blue. The brown looks, it's hard to see. Brown, black, blue. This one, you read this one by thinking of this, body, end, dot. So you look at it and go body. The body is yellow. End. The end is purple. Dot. The dot looks orange. That'd be 47K. What that should be. Resistors, as they wear out, my experience is they go higher and higher in resistance. I'm not sure they go lower, or that's a common thing. I guess it could happen somehow. This is probably related to the local oscillator, which is the main tuning feature in this radio. This radio for sure is going to be a super het, and the bulk of it runs at a fixed frequency, probably 455 kilohertz. Okay, there's the bobbin where the string goes in the two holes we saw earlier. The string is down here. How does it get back up? I don't know. It must just come down, go through the bobbin, and head back up. Gives you an idea of what the angles are. That's more than one way to wrap a string on one of those bobbins. Okay, there's nothing here that's making me think it would be a disaster to try to operate this radio. We'll take a look at the top part real closely too. In fact, I'm going to flip the radio down again. So one of the things I'm missing because I don't have the cabinet is there's no dial. There's no numbered dial here. This is just the backing paper. And to do the alignment, the last stage where you're tuning up the radio, and especially one with the string missing, as this one is, I need to position the pointer correctly. Now, usually there's a hint. So here's a bit of a hint. This is not the purposeful hint. See how the slider has been sliding back and forth here, and it's cleaned off this band, right? The slider. The slider. Where are you? I've lost track of the pointer. The pointer has disappeared. Anyway, the pointer is on a slider. It slides across here. Now, it looks like that could be a mark. I think that's a mark. What they usually do is they put a mark on the glass, on the backing plate, or somewhere, and they say with the capacitor completely closed or open, the pointer should be at this location. It's a very important thing to get right from the start, so that's why I'm looking so carefully here. There is nothing here outside of the scratch marks, which is better than nothing, and that end part there, I really don't know if that's a mark or not. So that's a little bit of a problem coming down the road. Not to worry about it though. If I really want the case, I can probably get it if I really think we need it here. Okay, looking at the capacitor. So it has two sections. One section is for adjusting the local oscillator frequency, and the other one is for adjusting a tuning stage, probably the antenna tuning. Fair bit of dust on it there. So I'm looking for plates that are bent and out of shape. I can just grab the big wheel here and turn it. Okay, I want to feel how stiff it is. Oh my gosh, I can't move it. Oh, going the wrong way. I'm trying to go out the indoor. Okay, so a little bit. Well, those plates all look wonderfully separated, and these ones. So this capacitor looks impervious to it because of its design and location, but occasionally people reach into these radios to do something, who knows what they're trying to do, and they squeeze these plates by accident. We'll open it right up. Moves very smoothly. Outside plates do not appear to be bent. You see how the outside plates have splits in them? So that's for a very careful alignment adjustment made in the factory to make the dial accurate all the way across, and to make the front end resonance. It's only the outside plates. So we take a look straight on here. It's a little awkward in this radio. Are they bent out? So on the smaller one here, it looks like this one is bent out. You don't want to bend that back. You know, oh, that got bent out, I'll bend it back. Don't do what I used to do a long time ago, try to straighten them out. It's probably bent out for a reason. And there's sections here so you can bend out, a certain, it relates to a certain section on the tuning dial. Again, usually that's a factory thing. Okay. But looks good. It looks good. Okay. What do we see about these tubes? Not much to see with a tube. You can see all the grid wires in there. Pretty fragile looking, aren't they? Okay, a cracked tube would have a white spot on it. You see where this is shiny here? This would turn white. Now, honestly, I'm not so sure about such old tubes, but certainly newer tubes. This is the getter material here. What is that? There's a guy making a run for it here. Oh, we'll just leave him alone. The getter material is a chemical that's inside the tube. There's a way to activate it right after the tube has been evacuated, or some point before the tube is put to work. And when you activate it, any gas molecules floating around still in the evacuated tube will collect on this shiny material here, which is mirror-like material. This one looks a little whitish, but I think I have a tube in here I can show that is cracked tube. I'll show you what it really looks like. These don't look bad at all. There I am. So I don't think there's anything, you know, obviously wrong here. All these wires look good. They look good in here. Don't think much has ever been done with this radio. Here's the cut wire. We're going to need to figure out which one of these is the ground and which one's the antenna. Good guess is the long one is the antenna, but it's only a guess. And a big transformer. Are you looking for goop coming out the bottom? No. Everything looks good. Very good. You know, this transformer is designed for 25 cycle and apparently 40 cycle. The higher up you go, the easier it is on these parts. That's my understanding of it. So putting a 60 cycle signal in there, or power in there, shouldn't be a problem. It's easier to filter and everything. It's harder to transmit 60 cycles down a transmission line, like a power transmission line, you know, across the country, than it is the lower frequencies are easier. A little bit of information there. Mr. H must have checked this out when they built it. Approved. Little did he know somebody would be looking at it like this. Yeah, with a camera in my hand, color, over the internet. Yeah, no, the guy who wrote that H had no clue what was coming, and you know what? We have no clue what's coming. That's for sure. Okay, a lot of wires going through a hole there, but again, they all look just fine. No sign of overheating or anything. Very good. So this guy is passing the visual test. Oh, the speaker. We should look at the speaker cone. Speakers will tend to crack around the edges here. That must be from that spider, that little web there. Okay, the seam is good. Everything looks good. J46A. So if there's a hole in the speaker cone, which is quite common, either gets poked in there by someone like me, or for whatever reason, you need to seal that hole up. So it comes with a sealing material here that would seal against the cabinet when it's in the cabinet. And it's important to make that seal work, but not necessarily easy to do. What you're trying to avoid is the air on the front of the speaker here leaking around to the back. You can think of that like an audio short circuit. High frequencies won't matter because the cone is going so fast. But low frequencies, instead of the air being pushed out at your ear, the air will scoot around the edge here. You think of your oar in water if you're rowing. When you pull on the oar, you're trying to push against the water. The water's trying to leak around the oar and get around the back. The bigger the paddle, the longer the journey, the more power in the paddle. Okay. Camera works perfectly. Very happy with that. Now, powering this guy up, seeing what it does. I really enjoy doing that, especially when, you know, I haven't done anything to the radio at all, but there's a really good reason for doing that. There's an obvious reason to not do it, but if you have the right stuff, you can do it fairly safely. The obvious reason is you can have a short circuit inside here. There's no fuse in these radios normally, so you'd be counting on your house circuit breaker. Your house circuit breaker is looking for 15 amps probably to trip, so you'd have to pump 15 amps through this for some short period to make your breaker trip. What if it's not 15 amps? What if it's 10 amps? What if this thing for some reason will only draw 10 amps? Well, you have 10 amps in this thing, and while you're wondering why the light isn't turning on, the transformer is burning up. So that's the main concern. There's some other concerns, but that's the main one. But I can see right in this tube. Let me get the close-up again. This is kind of interesting. If you look right in the tube here, you can see X. Somebody wrote an X on there. Well, how did they ever do that? I thought the glass was cracked there for a second, but well, they're making it. These things were made on a bench by a person, putting these parts together. Probably a woman. It's typical for women to do this work. There's another mark on that one, checking it off. Maybe the supervisor coming by, I don't know. Oh, no mark on this one. Oh yeah, there's a little mark. If that's an X or not, I don't know. Yeah, built by hand. These were assembled by hand. So they would have a tremendous failure rate. In fact, a lot of these tubes, earlier than these ones maybe, you buy them in a store, and the store would give you a guarantee. They'd say, I'll guarantee you 6 months out of that tube. If it fails sooner, bring it back, and I will credit you on the replacement tube. And then there'd be a sticker on the tube. I don't think there's any stickers on these tubes, where the date of the purchase would be written, so there was no argument when you came back to the guy. See, I bought it from you, and I bought it on this date, and the tube is shot. They were not terribly reliable. So it's a little surprising that if these are all original, that's a little bit surprising. Especially this guy. The tubes that run hard, that's the output tube driving the speaker, and the rectifier tube we're looking at right now. These tubes tend to wear out. It's by choice. If you wanted to build a tube to do the rectification that's going to last as long as the rest, it's going to be a bigger, more expensive tube. So that's kind of the deal. So we shouldn't be too surprised if there's trouble there. Okay, any other secret writing in here? Anybody writing a message? Hi mom, anything like that? It's not like a message in a bottle, isn't it? Okay, this one has a coating on the inside of the tube. So, these ones are, well, these ones have the getter material, but generally it's a clear glass tube. But this one has a coating on the inside of it. I couldn't really tell you honestly exactly why it's there. It's not there by accident. Okay. We're going to power this. Oh yeah, we need to figure out which wire is going where. So almost certainly one of these goes to the chassis. Let's make another important observation here. The metal frame of the capacitor is connected directly to the chassis here. Some of these will be mounted up on rubber grommets. That's a bit of a warning about how the radio is set up. That's maybe more typical in a transformerless 5-tube radio, a more modern, maybe 1950s radio. This one though is right on the chassis. So can we figure out where this wire is going here very quickly? So just in behind this plate, the wires are knotted. That's not terribly helpful. How can you tell which is which? Through the power of a voltmeter. Yes, I just half destroyed my shop there. Through the power of a ohm meter is really what I wanted to say there. Let's put them here. Let's go to the ohm range. Light on it, better camera angle. You can see it well enough. Okay, checking the 0. So I'm going to put one lead on the chassis, and I'm going to try to touch the conductors in here and watch the meter. Okay, I don't know, am I touching the wires? I may not be. Okay, this one I know for sure. Get it right on there. Ah, this is the ground wire. Aha. This guy's the antenna wire. Probably goes to one of these two terminals. Let's see if I can make that happen there. Once I have the schematic, we'll know the whole story. This could go to one of the terminals here or straight to the capacitor. So I'm looking at the meter. Nothing happening. Let me just turn this a little bit, maybe get it better. There, that's a little. Oh my gosh, my battery's low. It's bad news. This meter goes cockeyed with a low battery. Still gives you a number. So let's try here. Oh, it's coming up here. Let's try here. Oh, what happened there? Maybe I touched it with my hand. to resolve this. So I'm going to trim the wire. Okay, now there's no doubt about making contact. We'll try to ground again. Zero on both wires. What do you want to make of that? Let's put it down on a lower scale. Okay, so the meter says 0.035 on this one. 0. Okay, so that makes good sense. So we're seeing the resistance of a coil, probably this coil. That guy is the ground. This is the antenna. Good show. That's what it should be. Chances of it being done wrong is pretty low. Can happen, but pretty low. Very good. So now we know the antenna is what it is, and we got to come back and look at putting on the power cord here. So this is a non-polarized plug. We don't have the schematic, but chances are the 120 volts goes to the primary of that big transformer. It's down here. It doesn't go anywhere else. It just goes straight into the primary. Well, it goes through the on-off switch. Good. Straight to the primary, nowhere else. That makes the transformer in a radio like this an isolation transformer. By the way, there's a number of safety issues, of course, in a shop like this, working on a radio like that. I'm not going to go into detail what I do in my shop, but I do a number of things to maintain my safety, literally not the least of which is wearing rubber-soled shoes, standing on a rubber mat, and using an isolation transformer to supply power to the project. The thing about the isolation transformer is it's defeated when you start hooking up my equipment. My equipment in my shop is fully grounded, 3-prong type grounding. Even the 2-prong equipment, because I have a lot of vintage equipment in here with just unpolarized plugs like this, unpolarized 2-prong plugs. I have ground wires. You can see it's pretty light, but I have a ground wire going to each of those pieces of equipment. So there's no case voltage. I won't go into all that. If you're going to do this kind of work and all the things I just said don't really add up to you, then you need to do a lot of reading. And if you have a radio that has five or six tubes but no power transformer, you need to read up on the hot chassis problem, or you will learn it the hard way. And it's trickier than you think at first, the hot chassis problem. So I'm going to solder in that new wire, and we're going to plug this guy in, see what happens. Okay, so I want to fit the wire in. Okay, I just want to get the length roughly right. This wire comes all the way up to this terminal up here behind the capacitor. That's where this new wire's got to get to. Okay, so I'm marking where to tie the knot. Now, I could tie a knot here. What I am doing these days is I'm not trying to tie a knot. Tying a knot in these cords is not good, especially this newer material. You put tremendous stress in the plastic, you have tension in the plastic, and it will crack over time. So I do something, it's a little schlocky. I just use 2 of these guys inside and out to kind of lock it in place. And you know, if you boob it up, you can always fix it. In fact, I can do it later. I'll do it later. Okay, that's good. Trim these guys. Get rid of the old one. I'll try and desolder it. Get that there. just a beautiful, beautiful day here today. Temperature is going to be 20, 21 degrees, but the humidity is going to make it feel like 27, which is a balmy, sunny summer day almost. Even though here the leaves are changing color. It's a big, big thing where I live. I live in Ontario, in Canada, and at this time of year, the maple trees, their leaves change color. You know, I don't know how common that kind of thing is around the world. Maybe it is. But it's a big deal here. People look forward to it. Okay, I want to splash the solder on me. There we go. Some years are better than others for the fall colors. That's what they call it. Tourists come a distance to see it. And where I live, there are a lot of trees. A lot. I sort of live on, it's not quite accurate to say this, but the northern edge of civilization. It's really not accurate, but you can kind of think of it that way. South of me, in Ontario, is farmland and developed land, crisscrossed with roads and the like. North of me, it's much more wilderness. There's not many roads. There's large areas that are impenetrable. There's no way to drive into them. Okay, come on. A lot of solder here for my poor little soldering iron. You could drive, well, not again, this isn't really accurate, but it's kind of like driving 1,000 miles through the woods. Woods and the rock. There's a lot of, here we go. Now I'm going to splash the solder on me. I'm not careful. Come on out of there. There we go. Okay. I'm probably going to want to shorten one of these. Now because it's an unpolarized plug and I'm not worried about that aspect, I'm just going to solder one to one terminal and the other to the other. Let's see, it might be wise to tin these a bit. It might be a little short too. Let's get a little more copper here. So a lot of radio repairers at this point will put in either a 3-wire cord with a ground plug or a 2-wire polarized. So one of the plugs is wider on it. And then they do it in such a way that it's electrically sensible. I'm not worried about that myself. I don't do that. And some guys or people, some guys and girls, will also include a fuse in the circuit. I'm not saying it's a bad thing to do. I think it's probably a good thing to do, but I don't do it. I just put the radio back together the way it was originally. Part of my thinking on that, and you know, hit me if I'm wrong, is then I'm taking responsibility for the safety of the radio. I'm professing to have improved the safety of the radio, and I'd rather say this radio is exactly the way it was. Well, you know, exactly. It's the way it was when it came out of the factory. And I have not re-engineered any of it, especially around the safety issues like a fuse and stuff like that. Now, I'm sure this is a controversial thing. I'm sure if you repair radios and you put fuses in, you feel like, wow, you're doing the right thing. But you are. Because there's many right things here. There's many, many ways to do this stuff. Okay, so I'm just snugging the wire up so it'll solder up nice. Let's get that one in place. So what do I expect if we turn this on? What I think will happen is it will warm up and we will hear a hum. And that's about all. And it'll be a loud hum that we really can't overcome. There's no way to tune the radio or hear anything because of this gargantuan hum. That's what I expect will happen. That in itself is a test. That's telling you a number of things. It's telling you the speaker works. It's telling you power is getting to some of the tubes anyway. They're doing their thing. Mainly it's telling you this capacitor is bad. That's the main thing. And that's what I expect will happen. Okay, that's good. Yeah, so I'm going to cut this so it's a little more suitable here. A little excess. The last little radio I did, this kind of connection I'm making right now, had popped off in the radio, and one of these was just hanging out. I could easily come over and touch the chassis. Probably would cause some excitement, but maybe not. Now the chassis is at 120 volts, and you're getting ready to take a ride. A ride you'd rather not take. So, and the reason that happened was the radio, the cord was not properly strain relieved. I gotta make it a little more here. And one good tug on the cord just popped the overcame the solder and popped the wire off. So you want to make sure these connections are done really well. So that doesn't happen. The other thing is I'm using a stranded wire, of course, to get because the cord is flexible. It uses stranded wire. These wire strands, and I have not pre-soldered this or tinned it. These strands can end up places you don't realize they've ended up. So, in order to combat that problem, which I just realized, I'm going to bring on a little more light here. This might be a little hard on the camera. No, actually it's better. So I can see better. So the camera's vision is very different from my eyes. I'm not talking about I'm too old to have sharp vision. I'm talking about the way it compensates for light. So there are times where the camera makes it look very well lit in here, but in fact it's not. That's not the case right now. Sometimes I have to compromise with the lighting to make a good image in the camera, and bad for me here. Again, like if you're a new viewer, because I'm doing this essentially live, I don't get things necessarily sorted out 100%. I can't spend all day adjusting cameras and stuff because I'm trying to get this done. Look at that, and it is done. So now and then it's going to be a bad camera shot. Other bad things could happen. Usually they don't last too long before I figure out what's happened. I do have a large screen that I'm monitoring what things look like on a large screen up there. And again, if you're a new viewer, I have my actual computer operating screen over here. I hide nothing at all, except the camera crew behind me. I never let you see the camera crew, the producer, all those people. Okay, here we go. Now, without going into too much explanation here, because Mr. Google can fill you in on all this stuff, I'll just give you the key words. I'm going to use a dim bulb system. You see these two incandescent lights sitting here? In fact, I'm going to unscrew one of them. So these lights are in parallel, like they would be. And, two lights plugged in the wall are going to be in parallel. But when I'm using these lights, the power going through them, let me phrase that differently. The electricity reaching the radio is getting there through these light bulbs. Dim bulb system. I think that's enough to search on. And we need to plug it in. I need to move my soldering iron out of here. Okay, if you just heard a little bumpy sound, that was my head hitting the microphone. That's positioned right above the bench there. See it swinging? That's a stereo microphone. Everything's recorded in stereo. Occasionally I think is beneficial. So if you put on headphones, yeah, if you wear headphones, keep your hand near the volume control. Because occasionally things get suddenly very loud in here. Stuff goes wrong. Now we're going to plug this into my bench supply. Okay, so I have this box here. Again, I'm not promoting this particular box, but these kinds of things are really great to have around the house. They tell you how much power. You plug stuff in here and it'll tell you how much power the thing is drawing, give you the voltage. Very good. Okay, but I have other ways of knowing the voltage here. You see on the back is a regular old extension cord, just a 2-pronger. The 3rd prong exposed here is going nowhere. Not that it matters, it's just a 2-prong plug in there. But this wire goes back to an isolation transformer. Now you're probably looking at this and going, whoa, yeah, there's some isolation there. This is not the isolation transformer I'm talking about. I have another transformer feeding that. So even though the output here is a 3-pronger, no, not really. So if you're familiar with this kind of device, you might be saying, wait a minute, what you're saying isn't true. Yeah, it is true in my shop. What I would say about maintaining your safety in terms of all this stuff is better know what you're doing. You better have a really good idea, and you better learn from every shock you get, for sure. You better learn and do something different afterwards. As much as I try not to, I do occasionally get shocks in here. And every time I get one, I say to myself, could have lost your life on that. That's to motivate me, to look into it, to think hard, to stop, think hard about how did that happen. Take some kind of step to avoid it happening again. So I've only gotten one really good shock over the last 10 years, and it came from a capacitor up here on a 5-tube transformerless radio. I got a really good lift off it. So I'm going to power up my cord here. I have a couple switches which you may not see me operate, but you're going to hear them periodically. Sorry about all these wires that are in the way, but that's just the way it is right now. You know, I'm going to take that off because it's actually interfering with the switch here. So you can see a switch here and a switch here. This is what they sound like. They sound like that. They sound like that. So you're going to hear that from now and then when I'm turning power on. You'll know what I'm doing. This switch is the main power switch for my power box. Turns this light on, which you can hardly see. Now if I throw this switch downwards, the power will reach this outlet through those lights. If I throw it upwards, these lights are no longer in the circuit, and it's straight to Niagara Falls from there. Okay. Just double checking everything. It's not too much to double check. Let's put it down this way. Luckily my buddy sent this with the knobs. The knobs on it. Okay, I did not strain relief that cable, but we'll get to that. Too excited about starting it up here. First we want to make sure the switch works. So we turn it off. It's off. And I'm going to hit those power switches. So this is arming my system, and now the next click will be engaging the light bulbs. If the light bulbs come on at all, then this switch doesn't work. But they probably won't come on. Good, nothing happened. Just a double check. The outlet got 117 volts. Oh, that's right on the money. I can vary this voltage if I want with this device. This is another way to bring power up slowly and to control it, and this is a great thing. You can read how much current's going and all that kind of stuff. But I like the lights because it's so simple. Anybody can put this kind of thing together. Not everybody has access to one of these, but anybody can put together a dim bulb system, as long as you have some old incandescent lights. Okay, how are we doing for time? I think we must be around 45 minutes now. So I'm going to turn the power off, turn the power on. Now what I'm looking for when we do this, I think maybe I'm going to douse this big beam and light here, is one, you're going to look for this light to come on. Do you think it's any good? Let's find out first. Because if it's burned out, which they typically are, then I'm going to sit and look at it, it's not going to come on. And I'm going to think things that aren't true. This is an ever ready, well, it must be good, it's ever ready. 6 to 8 volt bulb, a little dark on the top. I can't see the filament. That's what happens as the time goes by. You can't see the meter. Action's down here on my dying meter. There we go. So it's good. Light is good. The light is good. Okay, so we can expect this light to come on. On a 5-tube radio, it comes on, gets dull, comes on again. This one is just going to come on and be on. So if it doesn't come on, it's not the end of the world, but it starts saying something about the radio. So switch is on now, volume is down. If I turn it on, it may hum right away, or maybe fairly quiet. And then as the tubes warm up and begin to conduct, they come out of the speaker. We don't want to leave it running like that, because it would just be so powerful on the speaker. So everybody ready? Let me just make sure my escape is ready, door is ready, everything's ready, I can escape. Okay, the exciting moment. It's not all that exciting. Here we go. So, oh yeah, lights. You got to see those lights. With these lights, just to let you know, when I first turn it on, the resistance of the heaters here is low. So extra current rushes in, but very quickly they heat up a bit. The resistance goes up and that current goes down. So the way it affects these lights is the lights come on fairly bright, and then they go down. Then once the heat is high enough in here, especially this rectifier tube, the high voltage gets distributed into the tubes and they begin to conduct current. At that point the radio draws more power and these lights will glow more. Big radio draws a lot of power, little tiny radio doesn't draw much at all. Some radios, like a transistor radio in here, wouldn't make these lights show up at all. So we don't know for sure what to expect, but something like that will happen. Can't think of anything else. Good luck to us all. Here we go. Lights on, lights on. Getting brighter. No hum. Volume up. Now we could have a dead tube in here too. We could have a whole bunch of dead tubes in here. We could have all kinds of problems in here. But no short circuits. If there was a short circuit, this light would be bright as can be. So far, pretty quiet. Okay. Now we're going to douse the lights here a little bit. Yeah. Because we want to look at the tube heaters. Who is heating up? Let's go with even less lights. Less lights. I can see with my eyes what's happening. I hear the radio. I hear the radio. Dirty volume control. No big hum. That's really surprising. I need to douse more lights. More lights off here. Made things difficult for myself. And this light. Don't burn your fingers now. Okay. Now we look at the heaters. Now the radio is warmed up slower than normal because a lot of the power is in this big light bulb. So it's heated up slower than normal. It's also running on less voltage, but we didn't really look how much less. So hard to see in the camera. Okay, I can move it a little bit like this. Every tube is lit. Thumbs up on that. Okay, that's the first tube test done. We hear sound. We hear crashy sounds. There's some light in here before I get into the trouble myself. What are we running it at? 85 volts is what it's running at right now. That's good enough. Good enough for now. The crashy sound can be all kinds of different things. It can be everything from a tube loose in its socket to a component failing, a resistor that's bad. It's just a long list. Let's see if we can eliminate a couple of them. These tubes won't be hot yet. So this is where you need your hand on the volume control, your volume control. Notice it's not volume sensitive. So I know it's in the cracky sound, probably in the later stages of the radio, but not necessarily. So this tube made me do something. Nope. 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 But it's not causing that crashy sound. Oh, this guy? No. Okay, we're now going to do the poor man's signal injection. I'm going to inject a signal. I have a signal in my finger. Remember, I'm wearing rubber shoes. I'm an isolated thing floating in space here. And I have signals in me of all sorts. I'm a really crappy antenna. But I can use my antenna. On the other hand, she's going quiet, which is a good or a bad sign. That may be a bad sign. Oh, no, I don't think so. I don't know what to say about that going quiet. Very faint hum. This power supply is actually not humming much. And that's a radio being received. That's reception on the no antenna. Let's do that. Oh, this radio's really working. Okay, now we're going to tune the radio. So this tells me that volume control now is working. A little bit of dirt in it. Because I can tune the radio and things happen. What happened? Things do happen. That tells me the local oscillator is changing, is working properly. Well, maybe not properly, but it's there. Okay. Now remember, there's no antenna on this. So these things it's picking up are probably noises here in my shop, noise signals. I'm familiar with the kinds of noise signals that are in here. There's a real boobity one. Should show up pretty soon. Boobity. No. The radio went quiet at the lower frequencies. Let's just get that edge right there. I'm trying to detect if the radio is flipping into oscillations. That's why it's going quiet. It sounds a little counter to what you might imagine. Okay, well we're gonna. Seems a little stronger at what I imagine is the high end of the band. Well, we're gonna give this guy an antenna and find out what it does. Let's just use this random loop antenna here. Not at all appropriate, but let's just stick this on here. Just more and more wire is a good idea too. Okay, volume down because I'm gonna put my hand on it. Okay, there we are. Is this in any way going to help? Now, this is not a proper loop antenna by any means. It's just basically more wire right now. What does more wire do for us? Oop, can't tune with this. The stations I can pick up are at this end of the band here. Oh, there's the boopity boop. Station's right in here. So the fact that it's not picking up anything, it's really not a bad sign at this point. So I'm going to stop the video for a minute. I'm going to energize a outdoor antenna in here, and we're going to try it with a whopper antenna. Okay, now it's time to start checking something else. How hot is this transformer getting? Not hot at all. Okay. If it were getting warm already, something's not right. That's not what's happening. This goes to an outdoor antenna. It has a long cable lead into it, but a pretty decent outdoor antenna. So this comes with a lot of noise at the same time though. Let's hook them up. Okay, a little bit of volume. Make it more interesting. Okay, I'm just going to hook up the single wire. Take that off. Didn't expect much from that anyway. There we go. Okay, now we stand a chance of picking up a station. There's the goobity goop. Now there's a group of 3 or 4 stations down in this part of the band, but one of them is fairly easy to receive here in my house, in my shop, and that's called the Fan 590. It's a sports channel. So if we listen to this just for a minute, we can figure out if that's what it is. Right? That's why I think coaching is a harder job. That's what he said. So yeah, that's the Fan 590. So in my shop, radios struggle to pick up AM radio. I'm not really close to any AM radio stations. The closest antennas are probably 75 miles away or further. So I'm just going to switch this off because we're pretty much done here now. Great. Not much left to do with this radio. Nothing seriously wrong with it. The biggest problem with this radio is there's no string. That's the number one problem. The number 2 problem, probably not really a problem, probably could stand a little bit of tuning, a little bit of alignment work, and a couple of those paper capacitors, I should change them because they just are not reliable at this point, even though the radio's working. Isn't that surprising? Is that surprising? People jump up and down when I don't plug an old radio in the wall. Well, don't plug it in the wall. Plug it into your dim bulb system and be safe. Well, that's it for today. So I'll be back in here tomorrow. I'll do the work on the radio and attempt to do the alignment and get it all done. So it'll be a two video production here. In the meantime, I'll find a schematic and hopefully a stringing diagram, and we'll know a little more about the radio, and there we go. Fantastic. So thanks so much for watching, and I really appreciate company while I'm doing this. That's how it feels to me, that I have somebody here with me. You're here with me. Just doing this work alone, it can be psychologically stressing work. If you're all alone, things aren't working out, and somehow shooting these videos makes me feel that I'm not alone with it. So thanks a lot, and see you on the next video.